Which of these integrals has the largest value? You're not expected to calculate the exact value in any of these. Okay, so we're given a bunch of integrals and asked which has the largest value. So maybe some of these we can figure out are like if the integrand itself is positive or negative. That might help. So I'm looking at option A, for example. Option A, the integrand is always less than or equal to 0. So that's not going to be the largest. The integral in A is going to be negative, right? If I write this integral out, integral from 0 to 2 of x squared minus 4 sine to the 8 of pi x dx, this is going to be less than 0. And some of the other ones we can see the integrand is positive, or non-negative at least. So this one is definitely not going to be correct. I wonder if any of these we can figure out are exactly 0. Doesn't look like it. Okay, so some other candidates for things that don't work. Options B and E have integrands that are not in fact, in E, the integrand is again almost always negative. So this is an integral from 0 to 8 pi of 108 times sine cubed x minus 1 dx. And this is also going to be less than 0, right? Sine x is between negative 1 and 1. So sine cubed is also going to be between negative 1 and 1. So if we subtract 1 from that, this thing is going to be between negative 2 and 0. So this is going to be less than 0, this whole thing. So that's not going to be the answer. I mean, I think the answer is probably going to be D, looking at it more closely now, but let's come back to that in a second. Let's look at option B, which is an integral from 0 to 2 pi of 2 plus cosine x cubed dx. Okay, so this thing here bounces around between 1 and 3. And if we cube it, that means this thing bounces around between 1 and 27. So if I just look at the integrand, this is between 1 and 27. Okay. And I mean, cubing things is nonlinear, so we can't. It's not like we can just take the average of this and multiply by the length of the interval, 2 pi. But just in terms of ballpark, in terms of approximation, let's keep that in mind. Let's look at option C, which is an integral from 0 to pi of sine to the power of 100x dx. So this is not going to be even close. This is a number between 0 and 1. This function is always between 0 and 1. So, and this is a function which is always greater than 1. So certainly option C will be greater than option B. So we can eliminate that right away. Finally, we look at option D, which is the integral from 0 to pi of 3 minus sine x to the power of 6 dx. And again, the integrand, 3 minus sine x is going to be between 2 and 4. And so when we raise that to the power of 6, 2 to the power of 6 is what? 64. So this is between 64 and something large. Call it m. The integrand, this function is significantly larger than that function. Like the minimum value of this function, the minimum value of this is 64. The maximum value of that is 27. And note that even though we're integrating over double the length, if I take this, if I assume that this is always equal to 27 and integrate over double the length, that is still less than if I assume this is equal to its minimum and integrate over this length. So the answer here is D, just by comparing the integrands of all these things. We can see that pretty immediately. Yeah, it's kind of a nice question. Really just testing. I'm surprised I didn't sort of hone in on options B and D by adding this constant like that to the trig functions with the exponent on the outside. You of course are going to make the range of the function extremely large. But yeah, just comparing the range of values that the integrands can take, you can figure this one out without too much mental effort. So yeah, nice question. Thanks for watching.